then inside that VM, we want to deploy Docker or Kubernetes, and then we go from there. We talked about the Docker in the past, but I'm going to walk you through it, how we're going to do it this time as well, and why we're using Docker and Kubernetes. I am going to launch again presentation here. So guys, my apologies because of my computer challenges. I'm just gonna open a brand new one. I cannot go to the other reference that I have, okay? So Docker / kube. Okay, now I'm sharing again. We go from the overall conceptual design to the one that we wanted as well. And I see my wife was calling me. I'm gonna answer her in a second as well. Because when your big boss is calling you, you cannot say no to it, okay? 1 second, guys. I'll put you on hold a second to tell her I'm in a meeting. Please call me back. Okay, I'm back. Okay, now let's talk about it. Okay, let's think about it. We have an application, okay? I don't care what application it is, we call it an application. For an application, I use this happy face because I am sure you all the time think happy customers, happy works, all the time, everything is happy face, okay? And whoever said no, I'm not agree with that, okay? This is my application, happy application, okay? Build this application using Node. We call it now Nodeme. Okay, so this is the application. Now, normally when I want to deploy this application to any systems, I need a server. This application goes inside that server. And this server gonna go to back. Perfect. Now, here we go. Now, we have Nodeme inside the server, but for the server to be able to serve Nodeme, I need to install, let's call that here, come on, here. Now, anytime that I want to update the Nodeme, I want to do a lot of things, what I need to do, I need to come back to the server, install Node, install additional software, software that I needed, and then also I need to do a lot of other things as well. But then this is the baseline for me, okay? Server has its own also its system, okay? Its own OS things here, okay? Let's call it OS or operating system files, okay? OS files, okay? And daemon files as well. Okay? So when we're talking about those, okay, then this one is part of my file, part of my application. Then anytime that I want to deploy it rapidly, I need to follow this process again and again and again, okay? It becomes challenging. I need to get the server, I need to deploy my application into it, I need to move forward from there. Now, why are we going to watch the Docker? Docker has become something like says, okay, you have your application, I'll give you something called container, okay? This is the bare minimum of virtualization of the application. You grab your application, Nodeme, put it inside, it likes me. Okay, get your node.me, okay, get it from here, put it inside this little guy, okay. Then let's send it to the, let's send it back. Okay, we can go. Okay, now, okay, good. So put it inside inside this. You call it container. Put it inside here. You tell me what kind of application is this application? If you're gonna tell them, okay, it is Node, okay, and then now is the node is there. Then what else you needed for this application to run? You're gonna say I need Mongo, but most of the time we don't put it in the same container, but Mongo in the other one as an example. Okay. So they said, oh, cool. Now I know what this the application is. Now all of it become a one system, this simple container. Now, where do you want to deploy it? You're gonna say, okay, I want to deploy it on AWS, on Azure, on Google, okay, GCP. And then what will happen? GCP has its own system, so you could deploy it on the GCP. Okay? 1 second. Something is coming to my headset. Is noisy, making noise. 1 second. Give me a second.
In the meantime, let's discuss what have you guys played around on GCP? Did anybody to give it a shot? Hello, are you able to hear me?
Yeah, we can hear you. I'm not. I haven't really played around with it much.
Okay.
Yeah.
So yeah, so I was asking Sean to help us set up the environment because it's the first time we are going to do, right? So if he can help us, and that'll give us a good idea, and then we can expand on that, expand from there, so we can take his assistance to set it up rather than trying it out ourselves. And he said, Sean said yes, he will certainly go ahead and do that.
Yeah. So I'm back, guys. My apologies for these things. You see, when you're having a new computer, it gives you all the hard times as possible. As an example, phones calling, distance calling, and that kind of thing that you set up that you didn't expect. Okay, we were talking about this. Are you guys able to see my screen? And are you guys able to see my presentation that I'm doing right now?
Yeah, you're good.
Okay, good. Okay, so we put it inside a container. We're saying that now I have a container. I want to deploy it to GCP, to AWS, or to Azure. These three providers, they have a framework. They understand the container deployment. Okay, they're gonna tell you, okay, now you have your container sitting inside the application sitting inside the container. We can give you two services, Docker or Kubernetes. Okay, okay. What are the difference between these two? Docker has a service called Swarm. Okay. But the beginnings when the Docker started and this is open source, when they create a container like this to put the application inside it, they create something called Swarm. Is the scalable deployment of the container. It will create different servers for you. And then when you deploy the server, deploy the container to them, what it does is just simply go launch it under the Swarm. Okay? A lot of computers that you can connect to when you're on your computer, most of the time, you set up the Swarm. Even though in the behind the scenes, when you're launching at the kind of Docker for the first time, you will see the Swarm, we call the light version of the Swarm is installed on your computer. And then you can go initiate it, even though when you do the initiations for the Docker Swarm, what will happen? The environment will set up to be scalable, even on the client side, okay? you will hear a lot about something called Docker Compose in the developer's environment. We all the time have something called Docker Compose. What it does, it will go compile the application, put it inside the container, deploys it in your computer, and it gives you a port. For example, you say, I want it to be run on a port 8080. I want it to be run on a port 9090. Okay, it will give you the port so you can see the application easily on the computer. That's a Swarm. Okay, and that's the Docker Compose. Okay, Compose light version of a Swarm, and the very high version of it becomes a full version Swarm, we call it. And it's simply, think about it, many servers. And what it does, it just do it this thing. It says, okay, you have a container, give it to me, I'll take care of the rest. You don't need to worry about the how many, how do you want to configure the OS, how do you want to configure this and that. Don't worry, I'll take care of those behind the scenes. And beauty of it, another beauty of it, in Swarm or Kubernetes, okay, underlying Linux OS, okay, we have two models of deployment, Linux and Windows for both, okay. Underlying Linux can be, for example, let's call it, can be Red Hat as an example, okay? But your container OS can be, and you can define the container OS, I'll show it to you as well, can be, for example, Ubuntu. There are two different words, okay? There are two different things. It means this in this node, it's working on the underlying OS is calling it Ubuntu, okay? So you see, something that never in the past was possible to run two different versions of things together, now it is possible. It is easy to able to run, okay? So that's the one. Then similarly as the Kubernetes, okay? So the Docker Swarm is simply an orchestration for the Docker containers. Kubernetes is another model of orchestration. Kubernetes getting more business than the Swarm, and the reason is that Google put their money behind of Kubernetes to set it up to bring it to the market. Okay, that was the biggest reason that the Kubernetes getting better response. Secondly, after that, a lot of people they saw a lot of flexibility inside the Kubernetes for enterprises. They deploy it. At the beginnings, it was nightmare for developers to set up Kubernetes in their environment. I can tell you that. Since 2020, that we have a mini Kube, which is a mini version of Kubernetes. Now Kubernetes getting very attracted to the world. Okay. Otherwise, a lot of medium-sized business to enterprises, they were using Kubernetes, okay? It's more mature than the Docker Swarm. Example of it, you could go inside the Kubernetes and you say, if I give you this container, first the containers in the Kubernetes, you give them a container, but you wrap the container inside something else, okay? There is a wrapper around of your container, okay? This is really a logical wrapper, okay? It's not the physical wrapper. It's similar to the container. It's a logical wrapper, okay? This is called, this little things here, this is called pod, okay? Pod, okay? P-O-D, okay? 1 second. And you're hearing this word a lot when you're doing working with Kubernetes. Why they calling it pod? Because think about it. Pod is representing similar as a server, okay? When I have a server, these applications can work with each other through a local communication. They're gonna be gathered together. When you wanna have that kind of flexibility inside your application, you put them inside a pod like this. I put this one, two applications inside the one pod, okay? But the pod, when you put them inside the pod, this is now your full application, okay? That's called the full application. With all the dependency to it, it becomes a one application, okay? And then it goes from there, okay? So this is the Kubernetes, this is the pod, and this is the way that it works, okay? having said that, 1 second, then the Google will give you the same solution as well. Now let's go to the Docker Kubernetes engine. I'm gonna stop this one. I'm gonna represent again from here, and I'm gonna show you how the Kubernetes pricing works. Okay. Tell me when you can see my screen as well.
You're good.
I can see it.
Okay.
Yeah, I can see your screen.
So I call the cluster something. For example, this is the sample cluster. Okay. Okay. So number of it says in here how many clusters you want to have. You say 1. How many AZs you want to have? You say 3. Okay. How many number? 1. So you see here. Now this is the one that I'm gonna say get the estimates out of the Kubernetes. Okay. For Node JS. Okay, regular machines, general purpose, and okay, RAM 3 gigs, 1 CPU. You don't need the GPU. Local SSDs, you do not need that. Okay, US Central 1, that's not bad. Okay, what we could do, even though you can go to the US East or US West as well, those are possible as well. So done commitment. For now, we do not use any commitment because for now it's like this, but later on we use the commitment as well. Now I twist. Now think about it. We just add those. It will cost us $243 per month to just run this application on the GCP. Okay, so this is the one. Okay.
So Sean,
Whatever.
it's so the workflow is going to be like Kubernetes, and on top of Kubernetes we are going to have Docker, and Docker is going to contain the VMs, right?
The way that it's gonna work is like this. Number 1, we commit or code into the Git repository that you have it. I'm not sure is the Bitbucket or is it the GitHub. Okay.
GitHub.
So then when you commit it over there, then what will happen after that? As soon as the commit coming in, the CI/CD inside the Google environment, what it does, it will compile that for us and put it on a container, an image. Okay.
So Sean, sorry for interrupting. What is the CI/CD? Is CI/CD Jenkins or Circle CI, or what is the CI/CD going to be like?
I am thinking to use our Jenkins, because if you use our Jenkins, then there is no cost here. But if you use any other CI/CDs, then, for example, Google, CKCIs, and the others, we have to pay them. So that's why I am going to use our Jenkins, and I will give everyone access to our Jenkins.
Our Jenkins is basically your server, right? Your server that you have.
The one that we are set it up. Yes, that's
Yes,
correct.
okay.
That's the Thinking Loud Jenkins.
Okay.
Yeah. So it comes everything to there, and then from there, when the application is compiled and ready, and then put it inside the container image is ready, then it goes to the Kubernetes.
Yeah.
Okay, this is the cost of Kubernetes.
So Sean, one more question. The CI/CD is doing all the workflows. What is the job of Kubernetes?
Kubernetes is launching an application. It's a compute environment application running inside the Kubernetes.
And what is Docker, and what's the relationship between Docker and Kubernetes?
The Kubernetes is the orchestration for the Docker. It's just a simple orchestration tool for Docker.
Orchestration, can you elaborate on orchestration?
That's correct. It's the management layer on the top of the Docker environment.
Perfect. If anyone of you have any questions, you can also question Sean while we have him here.
Yeah. Guys, go ahead. If you have any question, I'm here to answer.
You mentioned pods before. How does that relate in this process?
Okay. In this process, the pod is the one that we put the application inside it. Okay. We create a container image. Container image will be wrapped inside a pod, and we deploy the pods to the Kubernetes. Okay, and when we're talking about the pods, I show it to you. When you use it, then you will become something that is easily to understand, and then we can go from there. Let me do it this way. Okay, let me share my other dev environment. I'm hoping I have Docker here. Docker. Let's see. Yeah. Okay. Now I can share my screen with the dev environment, and then I'll show you. I'll present you a real Docker environment and how you can set it up on your computer. Once again.
Mike, is this meeting being recorded?
Yes, it is. I also recorded the last meeting too, but I'm also recording this one, and I'll put it on the YouTube and send the link on our Slack channel so that if you need to get back and see some of the things, you can.
Okay, thank you.
Okay, so this is my development server. I have a time I use it and that kind of thing. I shouldn't say development server. It's really Linux subsystem into the Windows. Okay, and then you could install the Docker on your computer, and this is the Docker. Okay, this is the Docker. It's a command. All the time it's the command line. Docker added additional interface just 2 months ago to their Dockers, but honestly, it's useless. I can tell you that. You need to learn the commands. The Docker life is on the commands. Okay, all these commands. Okay. Then let's launch a run test application. Okay, we say Docker run. Okay, this is the environment that this one that you're seeing it is Ubuntu. If I run a net system and cat the system, you will see is the Ubuntu I'm running here. Okay, I'm gonna do what I'm gonna do. I'm gonna run Docker run -itd. Okay, or you can say Docker run -it. Okay. These are, again, you will learn them later on. What are those means? For example, interactive and give me access to the terminal, okay? And then you're gonna say, let's say CentOS, okay? CentOS, okay? That's something that I do not have it in my system at all, okay? So I'll do it this way, and then I'm gonna connect to the command line on the CentOS, okay? So, it's telling me that it is not able to find the Docker. If the command line is there for the Docker, but it's not able to find the Docker to run it. 1 second, let me see what's going on my machine. Because as I mentioned, hopefully, it's the machine that I'm having a trouble with it. I go with that. 1 second, okay, what? All the time. This one going down. Okay, now I think it should work. Let me see. Okay, let's run this last command here. Now you see. Now what it does? It's telling you there is no CentOS installed on this Docker environment, or there is no images of that one. Now you download the image. Now I am inside my CentOS. How you can define it, how you can noticing it. You see here, it was on my computer. Now if you look at the naming here, it's saying it to you, it is on that computer, okay? So it becomes simply a computer, but if I, as an example, if I do yum here, this is I have a yum in the CentOS, correct? Yum is the application installer inside the CentOS, okay?
What is yum means?
APT,
is yum like npm, Sean? Yum?
Yeah, it's like as an npm for the nodes. That's correct.
Okay. npm for the node?
Yeah, what yum is like as a package manager, application package manager in the Rail model, or I should say in the CentOS, what Linux, you're using for the installing application is yum.
It's a Linux package manager.
That's correct. It's a Linux package manager for the what you call it, Red Hat model, okay, or Rail model, we call them. Okay. So we have 2 models of Linux. Most of the time you get used to it. You're noticing it. They have the Debian model and we have the Rail model. Debian, one of the one of the top systems or one of the defenses on the Debian. We have Debian Linux. We have Ubuntu. That is really it was the Debian and is everything is the Debian, but reality is called it now Ubuntu. Is very very popular. Everyone is using it. But reality is the package manager on that one is APT. But this one is the YUM for the one I'm running right now. Okay, so
Wait, Sean, I have a question about what exactly is a Red Hat? You keep talking about that.
okay, if you are working with the open source, okay, 20 years ago or 30, let's say more than that. Let's say around 50 years ago, 1978 or 1979. When the Unix platform is being developed, Unix is another operating system that a lot of us didn't touch it, okay? Or a lot of us didn't even know about it, don't know about it, okay? Then when the Unix is being developed and come to the world, it was very difficult to work with it. So people got the code of the Unix and they one of the co-founder in that company left from there, and HP was one of the biggest companies that were using Unix, okay? Then create something new called Linux, okay? It's another version of Unix, but called Linux. Linux, when they created it, they said, okay, we want to be easily able to install application inside this one. We should be able to have the interface for our users to work. But in that Linux system, then it becomes two variety on it, okay? One become lead by a company called Red Hat, and another one lead by another company called, what you call it? I forget. Red Hat, and the second one was
Debian, Ubuntu.
Yeah, it's Debian.
So in a nutshell, Red Hat is a flavor of Linux. So there are a lot of versions of Linux. One is Red Hat. One is the most popular. The very popular one is Ubuntu, right? Ubuntu CentOS is a lean Linux version. So different kinds of Linuxes are there. You can create your own Linux. Like it's an open source operating system, which means that anybody can take the code and make changes to it. So the big companies, they have their own versions. Like Oracle has its own version, or some other ones have their own too.
Thank you.
So simply now think about it. Now you can run all those versions with the one command on your computer. Okay, so simple as it is, and the container is that. Okay, so it's a very, very, very high level about the container and how the container is run. And you see me, I'm just running a Docker, what you call it, command here, Docker run and that one. And if I do it like that, Docker yes, give me a processor list. And then, yeah, of course, I'm running the Docker in the wrong format, Docker yes. So you see, I do not have any container running on the in the background, okay? So that's a baseline and how it works and how it's set up and how we can work with this environment, okay? What I suggest, let me set up right now, let me set up one VM first, it comes back online. And then after that, I'll show you everything else in the next meeting, which we can have it on Monday or the after Monday, okay? So I am going to again share my screen here, so it will give you simply what you need to do on your own as well. I am going to show you this one. I am going to the console, and then.
So Sean, our goal is by next week we have to have our APIs all online. We'll put our backend all online on our VM, and the team should be knowing how to use the Docker. Maybe once we set it up, we can have a lightning session on Docker, how to use it. I know there are a few commands that are there, and we can have individualized technology tear apart where we can learn those things. So Docker, boom, like the team can learn Docker, or how to use the GCP, or what parts to use actually, and Kubernetes, if at all we can. So CI/CD should be understood too. So do you think we can have everything set up by next week? like the whole environment?
Definitely. I can show you everything by next week.
Yeah,
for sure.
one last question before so, you can continue. The front end product is native, React Native, mobile. So that is not going to be on GCP, right? It's going to be on the Play Store, right?
That's right. That's gonna be on the Play Store. How it's gonna work is that I'm gonna show it to you. You're gonna have a Google account. Google, we call it console account, developer console account.
Uh-huh.
Okay, the Google developer console account, developer console account, Google. So it's part of a GCP now. In the past it wasn't, but now it is part of a GCP. Play.Google, and then what you could do, you could log into it now, and then publish your application there. Okay. The most important part is you have to accept their terms and conditions. Okay. Then when you review the terms and conditions completely, then it will let you log into the different what you call it Google accounts that you have, and then publish your application. I see we do not have any, or I do not have anything on the Thinking Lab that is related to the application that you have it. So you could publish the application, yes, in the Google App Store. And we're publishing it as the beta version, so we can go from there. Okay?
Perfect. Awesome. You can continue. You were what we were doing earlier.
Yeah. Okay. So let's go back to the Google again. I'm back here. I'm hoping you will be able to see my. I'm hoping that you can see my screen again. Okay. So I am in our project. Simply, I'm just going to launch the VM here. It's simple as it is. Okay. Create a VM. We're going to call it API as an example. And then labels. I don't want to add any labels to it. I'm going to say, okay, I want to put it in US Central to centralize for all of us. And then purpose, general purpose, 1 CPU, 4 GB of memory is more than enough. Okay. For the APIs of today. And then I'm not, you see here, I simply can say deploy container images to these, okay, using these image containers. But for now, I'm not setting it up now, okay? I choose the instead of Debian version, I am going to go to Ubuntu. Okay, and I'm gonna go to the Ubuntu, what they call it, 20.4 LTS. Okay, the disk size, I am going to put a 20 gig of disk space. Okay, and then select, allow HTTP and HTTPS. Yeah, you can also add a lot of things on a security level, so what you want to add there as well. And then simply like this, create. We create our first server right now, and it's this much simple. As you can see, it's just creating. It would take normally 10 to 15 minutes for the servers to come back online in GCP, compared to the others that it takes seconds.
So Sean, how do we?
The reason is that GCP, it has its own, a lot of security behind the scenes is running right now. That's why it takes time for it to come back.
So Sean, for this VM, so what are the different ways we can access it? Like from terminal, FTP, what are the different ways?
We're just gonna, through the terminal, we're gonna access it, but normally you do not need to log into it, because what will happen, I'm gonna terminate, oh yeah, it is off and running. Oh, no, that's good. You see it here, this is the external. You see connect to the SSH, you click on
so
the connect
Sean, can we connect to the URL too? Like we want to have the naming pattern where dev.api.hungerswipe.app.
Definitely. That's the one that I was trying to demo it today, but unfortunately because of the computer issue that I have, I won't be able to
do you need a GoDaddy account if we need to get the domains point? Because we have a website also which needs to be there, our root website. I think we can move it to go.
Where do you set up the current website?
Many. Where is it? Is it on GoDaddy? Bo, Many. Do you? What hosting do you have, Bo?
Say that again.
Where is our website hosted currently? Who's the provider?
It's a company called Godai, and the website is hungerswipe.app.
Yeah. So.
But yeah, the company's called Godai.
Okay,
that
and
we hired to make it.
Okay, and what about the domain?
The domain is hungerswipe.app.
I mean, a domain. Where did you book it? Is it on GoDaddy or Google, or which company did you use to
The domain's off of Google.
Okay, so Sean, the domain is the Google a domain provider, Sean?
Yeah, of course it is.
Okay,
Sure.
We got it from Google Domain.
Okay, perfect. So what will happen is we won't be using the other hosting, I guess. So we will move all the hosting to our GoDaddy account.
For sure. No problem.
Mike, your mic is up.
Oh, sorry.
I think it's my computer that knows. Okay, so this is our Linux environment. This is our Linux, guys. The VM is off, and then we need to install a lot of things inside this. Okay, but normally I don't go this fast. I normally set up my Kubernetes and I set up my nodes and then go from there. Then, okay.
So the way that you just showed us is with Linux. So are we going to be doing that one? Or you said that we're not going to be doing that?
Okay. Can you repeat again?
So the way that you just showed us, are we going to be doing that?
This is good for your purpose testings and all those things. But what I'm gonna do, I'm gonna set up everything plus in the Kubernetes. The nodes that you seeing at VM instances that you seeing there, you will see them later on, even though you install the Kubernetes as well.